Hey, what's going on, guys? GoMakeGames here. In this video, finally we will start implementing the core function of whatever chess engine called the make move. But it's closely related to the opposite function called take back, and both names for these functions are pretty self-explanatory. But let me explain some pitfalls that you might have encountered if you're a beginner and if you've never been writing chess programs before. So you might wonder that the matter of making move is just to initialize the target square with the content of the source square and then just to reset the content of the source square. But this is true only for simple moves like pawn moves like this. But if we have a look at the moves like castling, we also need to put the rook on the proper square. If we perform the double pawn push, we also need to set up the enpassant square in the square that the pawn has jumped over in order to just to initialize the enpassant square. If we do kind of our promotion moves, we need to specify the promoted piece and so on. So there are really lots of things to take care of while creating your make move function. But one of the most challenges is actually to not even to make move, but to restore the board position that was before the move is made. So let's consider two cases. So one case is when we would have been needing this is after we made a move, our king was actually found itself in the check, under the check. In this case, obviously we can do the move and we just need to take back. I'm not talking about this particular position, so just to provide an example, basically. And that's one case. And the other case, which is the most essential and most commonly encountered within the inner process of how the chess program works. So when we generate in the moves, let me just try to demonstrate you like kind of what's going on with the board. So it makes the first move and then it takes it back, then it makes the second move and then it takes it back, and then it makes again and takes back and makes again and takes back. So that's exactly the way of how the chess program is actually at least if we're talking about this kind of alphabet algorithms. So and this is the way how the perf test works. So in order to debug the move generator to make sure that it works correctly, so we need to make literally all the moves up to the given depth and then just calculate the number of encountered positions. But again, so there are always two options. We not only making the move, right, but we also need to take it back. And if it was only the matter of putting the piece back, it's not really a big deal. But if, say, we're capturing something, or we're taking back from getting our pawn promoted to queen, rook, bishop, knight pieces, yeah, or if we're taking back from capturing on the enpassant square, there are really lots of things to do in order to restore the position to the state where it was before this move. So it's way easier just to copy the board position before we're making a move, and then when we need to take it back, we just restore the board position from our copy. And I can't really claim this to be my own invention, obviously, but once I've shared this idea on the chess programming forum, and like it wasn't really welcomed that much, even though it's quite pretty it's quite pretty good in terms of performance. So it's almost the same time like if we're doing this take back stuff. So I've been testing this, but I didn't really see that much difference in the performance. So if we compare the resetting everything by hands back, like all the vast majority of board options available from the when we made move and just taking it back, or when we just restoring this from the copy. So anyway, it's way easier to copy the board and restore the position out of that copy, and it's the way to avoid producing really numerous number of bugs that could have appeared there. So anyway, it's really good for the beginners, and that's the exact approach we're supposed to be taking within this hexadecimal 88 board representation engine we're developing in this series. So without further ado, let me just close the browser and go to the source code, and I will now show you how to make I will define the make move function, but before that I'll just show you how we can store our board position and then restore it back. So probably I just need to open the terminal in the current working directory, and by typing make, I want to compile the sources, and if it compiles I want to run the chess hexadecimal 88 binary executable produced by the compiler. Okay, and oh my god, what happened? And now I just want let's use the tricky position variable here. So tricky position save. Okay, so to make sure it's gonna it, and now this would be the exact position we're supposed to be storing the state of. So the board position state includes the position itself, the side to move, castling right, enpassant square, and the king square as well. So let's actually try to implement this. So the very first and the most essential thing, so first we need to create our board state copy. So we need to define exactly the same number of variables needed to define the board state. So we need the integer. Let's call this board copy. Okay, so it takes exactly 128 elements to occupy, just like our hexadecimal board. And also we need this king square with up to 2 elements so the king square for white king and for black king. Then we need integers for, so not the king square, sorry, but king square copy, obviously, king square copy. Then we need the side copy, enpassant copy, right? Then we need the castle copy, and is that it actually? Yeah, it seems like so. Just to make sure that I created copies for all this stuff. So side, castling, enpassant, and position, and the king squares. So it seems like to be right. Okay, and in order to copy the board position, I would be making use of the C programming language, just standard string library called memcopy. So in order to make use of this memcopy standard function, we need to import or include this string library. So I can say include and string.h save. Okay, let me just try to see if it still compiles and runs. Okay, just forgot to put the semicolon. Okay, great. So, and now we want to copy board state. So it's kind of almost the same like here, but here we just define the variables. So maybe I should give a different commentary. Let's say variables. So board, let's say define board state variables, variable copies, this like. So define board state variable copies here, and here we just want to perform some action. So we want to copy our current board state. So the memcopy, the function we're talking about, takes up to 3 elements. So memcopy, this is how it is defined. It takes the pointer to the destination, pointer that points to the very beginning, to the very first element of the array we're looking for. So this board copy, then pointer to the source array. So here we just used our board, and also it needs we need to provide the size of our source array of board, but this decreases the performance slightly a bit because calling the size of function takes time, so it's better to hard code the value. But in order to know this, well, I already know that this is 512 bytes that's the exact length of our board, of the memory taken occupied by our board array. But let me just try to print this to screen to show you how it kind of works. So size of board, and this decimal string format in here, so I can just say size of and the board, save, and let's have a new line as well. So let me just show you this. We got this 512 bytes exactly. That means that we can use this 512 just right over in here, and this already slightly speeds up the process of generating moves, increases the time taken to perform this make move function. So okay, and let me just make sure that I did everything correctly. So now we need to say that side copy would be equal to side, and enpassant copy would be equal to enpassant square, and castle copy would be equal to castle. And now we need to do the same memcopy stuff for our kin square array. So I can simply say memcopy, and again, like so the size of the memcopy array would be, so 2 elements multiplied by 4, this would be 8. But again, I just want to show you this. So sorry, just again, like quickly print out the stuff here. So just to make sure, so size of kin square, it should give us 4. Sorry, 8. Yeah. 2 multiplied by 4. 2 multiplied by 4. This would be 8. Yeah, sure. So 8 bytes are occupied by this kin square. So now we need to make. Now we can use this 8 as the last argument there. So now we use this kin square copy as the destination pointer to the destination array. Now kin square as the pointer to the target array, and this is kind of it. And now this what I'm supposed to be doing now just mimics the behavior of the make move function, but I'm not going to be moving anything in this video, at least. I just want to reset the board completely to malform these variables representing the side, enpassant, castling, and kin square. So first, so let's say reset board state. So again, like this part now that I'm supposed to be making now is needed just to demonstrate how this copy works. So I can say for int index equals to 1, index is less than 128, the length of our board array, and index plus plus, and I want to say board index by the index is equal to 0 or empty space. Also I want to say side equal to, so initially it was white, so you see, like initially this is white, so I just want to set this to, well, I can't even set this to -1, if only it won't give me some segmentation fault. I'm not sure, but okay, let me just make it to just change this from white to black, so you see like it was kind of white here. So white means 0, and white is encoded as 0, and black is encoded as 1. So just set this equal to white to 1. Then enpassant. So do we have enpassant here? No square. So let's say enpassant to some whatever random square, like I don't know. Let's say make it E3. E3. Okay, and Castlin right. So now we have here we have the full-blown Castlin rights, but let's just make them equals to 0. So to disable whatever Castlin rights, and also kin square where the white kin lives. So now we have this at A1. At E1, let's make it like B1. Okay, so B1, and respectively the black kin square would be equal to B8. And I just want to print the board again to show you like what has changed. So print board. Okay, so you see, like we have no pieces on board at all. So imagine like something has changed on the board. Yeah, so something has changed. So the site has been changed. The Castlin right has been changed from the previous state, and peasant square has been changed. King square has been changed as well. So that's kind of it. And now what we want to do now is we want to restore our position, and I'm not gonna be using this restore code. Probably I won't even be using this in the next video, but I will comment this out at the very end, or maybe in the next video. So just to keep it, because we want to be reusing this later on quite pretty many times. Well, maybe not really that many times, but we would be reusing this still. So restore board position. Okay, and now we need to do what we do here, but in the reverse order. So here we're using board as a destination array to as the pointer to the destination array to copy data to, and board copy as the source array, and same here. So site would be equal to site copy. Well, it's quite pretty trivial with it's trivial with the single variables like this integers. It's quite pretty self-explanatory, but with this mem copy this is a little bit more complicated. But literally what goes under the hood, it just does this sort of stuff for every single element for the board arrays, indexes just through all the array. Well, something like that. So enpassant copy, and here we get this enpassant. So cancel equals to cancel copy, and here again just swapping these guys, save, and let's make sure it compiles and runs still, make sure there are no warnings. Okay, and I will just bring the board one more time. So just bring the board one more time. If I did everything correctly, it should restore the board here. Okay, let's check. So the board position, yeah, it seems like to be exactly the same, like just what we had before. So the site to move has been restored back to white. The Castlin rights has been restored. The peasant square has been restored to no square. King square E1 also has been restored successfully, which is absolutely fantastic. So which means that from now on, well, I will now so yeah, probably, yeah, I don't know how I'm supposed to be doing this. So I will just grab this entire code now. I just don't need the springboards anymore, so just let me get rid of them. So now this reset board state serves as the placeholder for our making for the logic of making the move, but I'll just get rid of this, and all the rest we can just grab this stuff and cut. And now I finally define my make move function. This would be the int type of integer, because it would be returning either true if the move is legal, or false. I mean either 1 if the move is legal, or 0 or kind of false if it's not legal, say the king has been exposed into the check, things like that. So in make move, and well, definitely it would have been taking the move to make, well, if it needs to take something else, we'll add this later on basically. So but let's keep it like this for now. So make move, yeah, pretty self-explanatory, and here I just paste all my stuff here. So we would be restoring our board position in case if king would be exposed to check, but I'm not I don't really want to this video to last that long, so I'm not gonna be doing this just right now. Probably I'll do this in the later videos. So for now I just want to comment out this part, okay? Also, we don't need to reset the board, and here we would be actually providing our make move logic. So this is just a placeholder here. So well, just to keep this placeholder, well, let's say like make move. So this source would be used within the next would be used in the next video. So just to give you an idea, like where the code would be starting. So just right over in here. Okay, save, and I'm not gonna be calling this make move function for now at least. So I just want to make sure that it still compiles and runs. Okay, and this would be probably it. So even though it might seem like it's not a big deal what we've done in this video, still this is absolutely essential stuff that really, so when you would see the amount of code being involved within the make move function, you'll realize that it's way easier just to copy the board state and just to restore it back, rather than to create the entire sort of a take back function that would be doing literally the same that make move does, but like in the reverse order. So there are too many opportunities to make a mistake, and that would crash the entire stuff. So just in order to avoid that disaster, we're just preserving this board position for the future take back, for the future move, for taking the move back in the future. Okay guys, so this is it from my side for this video. Hope you've enjoyed, learned something interesting out of it. Thanks for watching. Until the next time, and take care.